Dr. Daniel Gilford from Climate Central. Newly released information here today from NOAA on the upcoming hurricane season, and it kind of feels like a broken record at this point. Above average year. Can you give me kind of the basics on what this release today did say?
Yeah, so it's not that surprising results. We expect that this is going to be an above average hurricane season. And there's a couple reasons for this. One is that there's very warm sea surface temperatures out in the North Atlantic Ocean. It's quite hot out there. It's record breaking temperatures for this time of year right now that we're seeing out in the North Atlantic. And those warm sea surface temperatures mean that there's a lot of available energy for hurricanes to sort of pick up that energy, use them to strengthen and become more intense. There's also the situation where we're moving from an El Nino period into a La Nina period, and what that means that's sort of shorthand for the way that we expect the atmosphere is responding to the temperature of the ocean in the Pacific. And so, as the temperatures in the ocean in the Pacific sort of evolve, the winds that can affect hurricanes, specifically the wind shear, is starting to change in response to that as well. And so that we're having reduced wind shear, and what we mean by that is that a hurricane is almost like a spinning top in some sense. And if you sort of push at the hurricane from this side, if you're pushing the same strength all the way from the top of the storm to the bottom, it's just going to move right along, right? But if you push really hard on the top of the storm with the wind, but not so much on the bottom, the storm starts to tilt over, almost like a spinning top that you bump. And as the spinning top gets bumped, right, it loses its stability and starts to wobble. And the same thing can happen with a hurricane. As it sort of gets bumped by this wind shear, it can sort of start to tear itself apart. Well, we know that as we move into a La Nina season, like we're just about to, the wind shear goes down. And so there'll be less opportunities for storms to be arrested by very strong wind shear. And so there's a bigger chance, sort of the opposite side of that is that there's a bigger chance for there to be more powerful storms that are unabated in this hurricane season.
Okay. So what's the timeline here on that shift from El Nino to La Nina? And does that impact the season and when we may see these pop up or not pop up?
Yeah, so the La Nina shift is already taking place. We can see that in the data. The numbers that they put out this morning was that something like 85% of the time. So basically 5 out of 6 chances. So if you roll a 6-sided die, 5 of the times that a number comes up, we would expect this season to be responding as above average. So this really is sort of unprecedented. The conditions are ripe for a very intense hurricane season coming up in 2024.
Okay, so that's kind of where they got this season's forecast from. You're with Climate Central. Can you tell me the role that climate change is playing in this, and then how you know that?
Right. Yeah. So climate change is playing a role through both changes in wind, changes in the amount of fuel available to storms, and changes in the water that surround hurricanes. So we know that hurricanes are kind of like giant heat engines, almost like the engine in your car. Actually, as you add fuel to the engine in your car, the car itself starts to move faster, and it's the same with a hurricane. As you add fuel to the hurricane in the form of warm sea surface temperatures that the hurricane encounters, it starts to spin faster and faster. We know that the climate system itself is warming up as we add greenhouse gases all across the world. Since the time of the start of the Industrial Revolution, we've been adding more greenhouse gases to our atmosphere. That traps in more heat onto our planet. That extra heat then gets down into the ocean, and when a hurricane comes along and encounters those warmer sea surface temperatures, the sea surface temperatures are more than 1 degree Celsius, so more than 2 degrees Fahrenheit warmer than they would have been, say, 100 years ago, or in a world without human-caused climate change. And we know that those higher sea surface temperatures can drive more intense tropical cyclones, more intense hurricanes that could then be making landfall. We see this in the data. There's been an increase in the amount of Category 3 plus, so what we call major hurricanes, over the past 40 years. There's a very significant increase in those. And that's consistent with the idea that these warmer sea surface temperatures drive more powerful storms. There's also a couple other things changing. I mentioned the water earlier. A warmer atmosphere like we have right now compared to one without human-caused climate change means a wetter atmosphere. That warmer air can hold more water, and when that extra water gets up into the atmosphere and encounters a hurricane, it has to come down, right? And so we're seeing an increase of about 10 to 15% of rainfall associated with hurricanes. We saw this, for instance, with Hurricane Harvey and Hurricane Ian, where some colleagues at Stony Brook and NOAA put together research that showed that Hurricane Ian had about 15% more water and rainfall associated with it than it otherwise would have. And the final thing is storm surge. We know that sea levels are rising all across the planet, and especially along the United States coast. And higher water levels mean that there's more opportunity for that water to get picked up by hurricanes as they come along and brought on shore in the form of storm surge. So higher storm surges, more rainfall, and more intense storms are what we can expect in a world with human-caused climate change, like the one we have.
Yeah, and I want to bring up something that we kind of saw last year, maybe a couple of times, is this rapid intensification right before landfall situation, which is really terrifying. But definitely we saw it last year, at least on the West Coast. So can you tell me anything about sea surface temperatures that are really close to the coastline, and if that's something we can expect this year or even worse this year?
Yeah, so some of the research we're doing is showing that the sea surface temperatures, for instance, in the Gulf of Mexico along the coastline, they can be quite a bit warmer, and in part that is caused by human-caused climate change. We know that these sea surface temperatures, when they're encountered by a storm, they can sort of see that those warm waters, and almost like a car that's sort of gobbling up the fuel as you hit the accelerator. We're sort of hitting the accelerator on these hurricanes with these warm sea surface temperatures, and we're seeing these rapid intensification events become more frequent in a warmed world. And so we expect that this is pretty consistent with the way that we've changed our environment. This warmer atmosphere and ocean means that hurricanes now can grow more strongly into more strong wind speeds more quickly than we had seen in the past. And so what that means is that communities will have to be really vigilant to think about, if you're in the path of the storm, how do you need to prepare? You should always be thinking about that if you live in a coastal community along the U.S. Gulf or East Coast, because these hurricanes, it really only takes one to devastate a community. And so preparedness is key.
Yeah, and we see these outlooks come out, and there's numbers, but it doesn't necessarily mean that they make landfall. These could all be out to sea and not impact anyone. Is there any research or any forecasting on tracks? Is there any way of knowing where these potential storms would go?
Yeah, so as the atmosphere and ocean warm, that tends to sort of expand the range of the tropical atmosphere. So that means that hurricanes tend to be tracking a little bit further northward. But that doesn't mean any individual storm will be tracking further north. So it's important to keep the difference between an actual particular storm that's out there and the trends we are seeing over time. Like we mentioned before, it really only takes one storm to devastate a community. So I think probably the most important thing is that there's going to be changes in the intensity of these storms, and that could lead to more devastating impacts when the storms arrive.
One last question. I know you work a little bit on attribution science at Climate Central,
That's right.
and there's been a lot of work done there as far as precipitation and temperature. But what about big events like hurricanes? Can you attribute specific hurricanes, to climate change?
That's something we're actively working on right now at Climate Central, and I don't have the full results to be able to share with you right now, but I can say that it seems that as we are increasing the temperature of the atmosphere and the ocean, there's also more fuel available for these storms to grow. So we're getting an inkling that the increased fuel in the North Atlantic Ocean tends to be increasing the intensity that these hurricanes that we've observed over the last few years has shown these really intense wind speeds increases in sort of the proportion of storms that are category 3 or higher. That's all consistent with these warmer sea surface temperatures that we know are caused in part by human caused climate change. So there's definitely a connection there. The extent to which it affects any particular storm varies, but there is certainly a lot of evidence to suggest that as we increase the temperatures of the ocean, there's going to be more fuel available to these storms to grow more powerfully. And any given storm that could be encountering those sea surface temperatures could be influenced by that climate change effect.
Dr. Daniel Gilford, thank you so much for your time.
Thank you so much for having me.